is the FRC Roundtable, coming to you all the way from Minnesota. Your host team 2052 Nightcrawler presents this weekly FRC gathering where FIRST Robotics competition teams take cooperation off the field. Share your knowledge, give and get advice, solve a challenge, or celebrate what makes your team special. 3, 2, 1, go!
All right, recording has been started. Welcome, everyone. I want to first start off with a big thanks to Isaac, who signed up early in the week so that I didn't have to worry about who was going to present. So thank you very much, Isaac. And just a reminder for everyone else, please consider signing up to host a talk. I will reiterate this every week going forward because it's been so positive. If you are interested in presenting a get to know my team, I've heard a lot of people talk about how great of an idea that is, and they want to see more of that. So if you're interested in giving a presentation about your team, please do that. I'm sure I'll remember to plug that again at the end of the talk. All right, well, without any further ado, Isaac, the floor is yours. You want to introduce yourself and kick off our talk?
Yep. Hello. Can you guys hear me? My name is Isaac. I'm a senior on 2052 Nightcrawler, and I'll be giving a talk at Jumpstart about kind of tips and tricks for operating CNC routers and some lessons learned from in-house machining. So I guess a bit of an agenda for tonight. This is going to be going over my Jumpstart slides and kind of practice. Feel free to like raise your hand in the call or like speak up at the end of slides or when I'm done talking. And it would be nice if you have any feedback at the end to give it, because this is really my first time practicing in front of a group for this year's Jumpstart. So yeah, so a bit of an agenda. We're going to go over my qualifications to give this talk, some pros and cons that we've learned for in-house manufacturing and dealing with the cons, and then tips and lessons in all those categories. Then hopefully some dedicated time for questions. So some of my qualifications are I've spent 2 years with using CAM programs and CNCs, including this year's build and competition season. On the left there, I've got a picture of all of the milled parts on our 2024 robot Scarab. I think it's about 49. Then I've also got 2 CNC routers I've worked with. I spent the majority of this summer tuning and improving our team CNC, and I'm our team's CAD-CAM lead. But I am also an amateur machinist, so don't take me as an authority in anything here. So here's some pros and cons of, oh, sorry, there's a thing at the top of my screen. Here's some pros and cons of our in-house manufacturing. So it's nice to be able to fix or modify parts during production, say halfway through a cut, we find out the part has a flaw, we can just stop it, and we don't have to waste a couple days in like fixing that. And in kind of the same vein, we have a quick lead time, maybe about an hour between finalizing a part and getting it ready for being put on a robot. As opposed to, I'm not sure how long the lead time is for other teams, but I've heard it can be pretty long. Then also operating CNCs gives valuable experience for the students on the team, and also insights into optimizing designs for manufacturing to make it quicker or easier or even possible if your design is not really optimized for that. Then the last pro I could think of was after your upfront cost, you only have the material and tooling costs as opposed to paying for a part to be professionally milled or having a sponsor have to do it. So some cons with that are there's a time investment in setting up the machine, learning to use it, setting up new tooling, There's also a steep learning curve in learning how to actually do all those things and in getting your parts to go quickly and not destroy your tools as you go along. Then, if you have a student doing all of your CAM work, it pulls students away from design and from other tasks they could do that they might prioritize. Um, there's also the high upfront cost and the cost of shop space that the CNC takes up. So some ways we've dealt with cons are for the time investment issues. I've dedicated my off season to setting up the hardware, software, bit profiles, getting our CNC ready for the challenges of the season. Then also you can experiment during downtime. Say you just finished your last part for the next 20 minutes. You can do some like test cuts, work on improving your tooling, stuff like that. Then for the learning curve issue, you can start off by milling with easier materials, say wood, plastic, and there's many videos and tutorials to learn the best practices. I've seen a lot of stuff from Tines of CNC and Stony CNC. I've actually incorporated some of what their videos have taught. Then you can also use your alumni as sponsor connections for resources or help. We actually had a alumni from 4 years ago actually help set up our CNC for the 2023 season and got us started with tooling and like showing us how to actually operate it. Then for dealing with pulling students away from design, you can either have a mentor who's willing or able to machine if students, it's not a priority for your students to machine, or you can have multiple CAM students to switch out machining duties. Or what I like to do is just CAD outside of meetings using all the available time that's not for schoolwork. Then if you have a limited shop space like we do, we have a very small closet. You can place it in a shelving or low traffic area. We had it in the back of the shop for a year, and now it's like tucked away, accessible but out of the way. And lastly, for that, you can also put the CNC in a mobile enclosure and just wheel it around. Then, okay. Anyone got any questions before I move on? Cool. So now some tips and lessons from my experience. Oh, Sam, what's your question?
Yeah, sure. Yeah. So you mentioned the pros and cons of doing it in house. Does Nightcrawler have any experience like doing having a company cut things, or how did you guys land on doing most of your parts in house?
I'm not the best person to ask about that because
Sure.
we got the CNC the summer of my freshman year. Scott, do you want to answer that?
Sure. So Nightcrawler really started CNCing our own parts. I think we did one, maybe two parts on the school's X-Carve, and one of our students who had taken shop class knew how to do that. But again, it was just one or two parts. It was a very limited functionality for us. And so one of our students who was, I don't know if he was the build captain at the time, but he became a build captain. He had done it on the X-Carve. And then that same student, he dumpster dived and pulled out a CNC that the school had thrown away because the control board, it had to run like on Windows 95 and the motors were shot. And so the school was throwing out the CNC. It ended up in the trunk of his car, and he took it home and he put it in his basement, and he went on Amazon and he bought all new stepper motors and he bought all new control board, and he basically made his own CNC and reused the frame and the spindle. And then he ended up cutting all of our parts in his basement for the next 2 years. I bought a CNC. I bought a Shapeoko. Again, it's a desktop CNC, a benchtop CNC. I ended up cutting most of our parts after the year he graduated, and then we decided we needed to own our own CNC. And so I would cut our parts in my workshop that I have here at home. And it wasn't that many, though. It wasn't until we actually had our own CC. Like, I don't remember what you said, Isaac, 40 some parts. When we were milling our own parts, when Kyle was doing them in his basement or I was doing it in my shop, it was probably 10 or fewer. And now that we have our own CNC, all of our gusset plates are pretty much custom, and we can just do a whole lot more since we have it available to us at every meeting.
Yep. Thank you, Scott. Anyone else have any questions? Okay, I'm gonna move on now. So some tips and lessons from my experience. First off, secure. Jeremiah, what's your question?
Sorry about that, Isaac. Quick question. So some of the parts that you have to mail out to you, do you have to design them yourself, or is there like, if there was is that a template somewhere? Somebody made it, share it.
Well, a lot of parts, I'd say most of them we design and then cut out ourselves. But there are some parts like the thrifty bot bearing hats where we can just take the step file and then cut it based off of what they've released. Does that answer your question?
Thank you.
Okay, so to start off, for preparing operations, there's a lot of ways to prepare stock. We used to only really use screws and hold downs, which are good for sheet goods, but they can bow your material, and screws especially can do a lot of damage to your wasteboard and need holes in your part to secure. So some other things I've been experimenting with are tape and super glue, where it's good for thick stock and you don't really need to add extra holes to hold down your part, but you really need to have careful control of your heat and torque on your part, so that the adhesive on the bottom of the tape doesn't like start to melt and your part doesn't fly away. Then another thing is, or another way of work holding is using a mounted vise, which is really good for like smaller, thicker stock, but it really limits the size of your parts, and you gotta account for some special things with that. So I've got a picture here. It's of a part that's got a hold down and some screws. These hold downs, something you need to really account for is it's harder to do larger parts because they take up um, maybe 2 inches or 2.5 inches of your wasteboard to the side of your part. So that limits the size of your stock you have. And it's a good amount of effort to put the screws on because you can't just uh, cut out your holes and keep going. You have to cut out, pause for like maybe a couple minutes to secure the part, then keep going, which the long run isn't too much of a hassle. Then I've got a vise, or got a picture of just using some screws to hold down, very haphazard, and then a vise that I made. And something to keep in mind with using vices is you need, uh, when you're actually doing a contouring operation, you have to leave some clearance so that you don't hit the top of the vise, and that means that there's this little like pad at the bottom that you can't cut. So you need to flip it over and then mill off what you're holding on to before. Because if say you were to take some material off the sides, if you were to go all the way down, you'd cut into the vise and then it wouldn't hold anymore. I think I've got a picture in a later slide to demonstrate this better. That's something I'll be adding later. Then I've got a whole slide for taping and gluing parts. So if you're gonna do taping and gluing, you're either gonna want to secure a piece of aluminum or some material that you can flatten, like in the top left picture, or you're gonna need to have a flatbed that you can trust to tape down on. So in the bottom, like the bottom picture and the picture on the right side, that is some material that I've based to get a flat side. Then on both of them, I flipped it over to get a flat side, so I had as much contact with the tape and with the part as possible. and this is with a surfaced wasteboard. So it, to really get a good stick with your tape and to keep large parts on, or especially smaller parts, you need to make sure you're dealing with the heat and have something flat to work with. Um, then another thing about like preparing your operations and actually mounting them is it's really nice to have a way to square or align your fixtures or stock that you put down. So one way to do this is dowel pins, which I've played around with a bit, to like either mill a hole into your wasteboard or into your CNC or your router table, and then put a pin in there that you can brace your part up against, which is nice. Say you're doing a really small part and you're gluing it and it flies off. And when that's happened to me using dowel pins, I can just take the tape off, retape, re-glue, then put it back exactly where I am and keep on going with the new operation without even having to change to zero. Um, Another way to like make sure you have a really accurate part, or you have a really square and secure part, is to if you're using a vise, um, square it up against your CNC or your actual router table or your wasteboard, and just I guess using a square as your reference. Then the last thing I want to talk about for this slide is squaring the side of your wasteboard. So if you look in the bottom image, there is like kind of a ledge on the bottom of the wasteboard. That's because I ran a 1/8 inch bit along the side and just cut that side of the wasteboard square so that I could put a square up against there and know that my stock or like whatever I'm referencing off of it is square using a square. Um, that was a lot. So if there's any questions, just feel free to like raise your hand or I guess make it known. So then another thing about like actually preparing your operations is a lot of the time your stock isn't flat, which is really annoying, but um, because it can cause slight inaccuracies in your part, and it might lead it to not mount correctly onto your where you're actually mounting it on the robot, or it might not be easy to put on the router. So a couple solutions is to like fasten the stock with, if it's like sheet stock, fasten it with the concave side up so that you can force the sides of it flat and you can cut it just like normal and compensate for the bowing of material. Or if it's, say, a thicker piece of stock with a variable thickness, depending on where you're measuring, you can run a face operation, just up ah, taking off enough material to flatten it. Then you can either just go from there or flip it and then flatten it again so that you just have a nice flat surface on both sides. So I've an extreme of example of some like bowed sheet metal. So on the top image is just some like zero point 0.1 aluminum for reference, but the bottom image is a piece of stock we've had forever. That's like 0.125 inches, but it's practically useless because just how much it bows. So some, if I were to use that, I would I've in the past cut off small strips of it to like kind of deal with the bowing because it's less extreme over small areas. Or if I really needed to, I could secure the ends and just really screw it down. Then, say you really want to go for accuracy in a part, what I like to do is to test tolerances. I've had some bad uh, bad experiences with just trusting what I put in CAD to be accurate, especially using, say, a hex shaft or press fitting. So some ways to kind of deal with or make sure that your part is as accurate as you can make it is to do a finishing pass where you go down and you do a full you cut the full depth, but then you leave some material on the sides to take off later with like really small finishing passes, or spring cuts where you like either have extra cuts where you just mill it normally, then you run your bit along the edge a couple times without taking off any extra material to deal with deflection. And so it might cut extra material than or more material than the first pass, just because the bit had more force pressing it up against it and deflecting it. So to get really flat sides or flat cuts and a really accurate part, it can help to do a spring cut. Then say you're doing a hex pocket like in the image here. Um, so when I actually made this part, uh, I tested the tolerances in some pieces of scrap, but then I also went back and on the final part, I milled out all of the press fit and the hex holes. Then I just went and put in a hex shaft into the hole to test it while it was still on the CNC, still secured, so that I could rerun an operation and expand the hole a bit if needed, and then just keep guessing and checking. And so I've got I've actually got the piece of stock that I was testing on. Also got it right here. So in the picture, I have a lot of hex holes, a lot of those little like dog bone holes here. And so I just went and ran a ton of these operations to try and dial in the dimensions in the CADs that had the right tolerances, and so that I could get a really exact fit. And then speaking of accuracy and fit, so a really wild concept. Milling tools are round, but something that is like less obvious is that means they cannot cut sharp concave corners. So I like to add pockets to corners and then use small tooling to minimize the size of the pockets. Or if you really want that to be a sharp corner, you could file it down and file the part. Or if you're putting a fitted piece in there, you could round the edges of the fitted piece. So I've just kind of got a diagram. Sam?
Yeah, sorry, I didn't mean to interrupt you there. But I was curious, so when you do that, when you add those little round, do you do that as part of your CAM operation, or do you actually go back into your CAD model and do that?
Oh, that's a great question. I do in the CAD like a little, kind of annoying to do, but I take an arc and then I like set the radius and then I just make it. What's it? I put the midpoint of the arc on the like tip of the hexagon. Say I'm doing a hex slot, so I do add that in CAD.
Okay.
But I've got a little diagram up here of without the pockets. So since the bit is round, it's not going to be able to enter into the corners, and I've found that Fusion does not let you just like overcut to make sure you get a sharp corner. It just rounds it for you, and so this can be negligible if you got like a 16th inch bit or something. But with like an 1/8 inch or a 1/4 inch, you need to add pockets just so that you can tell the end mill to go straight in there and actually get your hole. So I add a little radius to all of my 90-degree interior 90-degree pockets. Let's see. So say I want to secure a bit of stock with screws or hold downs. I always make sure to, and I've had issues with this in the past, I always make sure to offset my zeros so that I'm at least like 1.5 times the bit diameter from the screws and hold downs. Because when, say you're to do a like outside cutting pass on your part, if you don't do any offset at all, there's a chance that you run into the screw, and that I've seen a lot of sparks fly, and I do not want to have that happen. So just adding a little offset can prevent you some tool wear and just make sure that say you are just cutting out of a piece and you're right on the edge of it. And then that offset can also make sure that you don't run out of space on the side to cut. Dr. B said, oh,
Hey,
yeah.
Isaac, thanks. I'm from 2530. Thank you for this, by the way. It's really, really cool because we're just starting our adventure figuring out how to do this. How do you secure your waste board? I can see that you've got this part which needs a lot of screws because it'll probably bow screw down into the waste board. Do you have T-nuts that go into the slots that keep that down?
Yeah. Where is it? Yeah, so we have T-nuts that slide into these slots, and then it's hard to see in this photo, but like right here, we have like some button head screws. So we just do T heads and button head screws. Then we don't slide the T-nuts in first. We put them on the actual waste board, then slide it in just for ease of putting it in.
And then you'd square up the board by cutting the edges with the tool, and then you'd surface the waste board so that it's flat, and then you do all your stuff.
Yep. Where was I? Oh yeah. So add a bit of offset. Then also, if you're using vice jaws, make sure your lowest Z pass is above your jaws, just so you don't have to go and remill those, or remill those because you ran into them. So any more questions before I move on? Scott.
Isaac, when you're setting up your finishing passes so that you can take care of the bit deflection when you're doing your regular cut, are you just doing one finishing pass, or are you doing multiple finishing passes?
It depends on the part. I like to do like one finishing pass if it doesn't need to be too accurate, or maybe even none if it doesn't need to be that accurate at all. But I would go to if you're trying to actually get like a press fit or a close fit, or maybe even 3.
And then I know that you've done a ton of optimizing over the summer, and I haven't seen the results of all that stuff, but in the past I would, and I think you did as well, when you're cutting stock that's bowed, we would always set up a couple of air passes. At least I always set up air passes so the bit would run along the top and it shouldn't touch anything. But if your flat stock is bowed, it ended up taking some off so that you wouldn't take too big of a bite with your end mill and end up causing chatter. Are you still doing that, or is the way that you've set up your milling with ramping and stuff, does that alleviate the need to do air passes?
A lot of the time I ramp into the material, so I just ramp with like maybe 100th or like 5,000ths of an inch, like above the material, or I start like 100th. Yeah, 100th or like 5,000. So I still do a bit of that, but not too much.
But you're just starting your ramp higher. You're not doing a full pass in the air. Okay.
No. Okay. I'm gonna move on now. So, this is a fun part. So I've had a lot of operations fail on me, and so one of the ways I like try and prevent that, or to stop it from damaging the machine or damaging a part further, is to like have a hotkey to actually like digitally e-stop the machine. If you A lot of the time, if you have a physical e-stop, like a button on your control box, that actually turns off the machine. So you want to use that as little as possible, only in like an actual emergency. So um, I like to use a little like what was it, a little number pad, and then I have I use the N key as the hotkey for e-stopping. And so like if you do a digital hotkey, or you actually click an e-stop button in your software, or like you have a stop button on your pendant, that can interrupt the cut, so that and like maintain your zeros so that you can just keep on milling after you've solved your issue. So say you have a part that you forgot to secure and you started a cut, you can just pop that button, like move your spindle, secure it, then keep going. So I always like to have this like track or number pad always ready, always holding it while a cut's going on. Then say you actually lost your zeros. Say I don't know, you had a power outage during an important cut, which actually happened this last year. You had a power outage that you lost your zeros. You can a couple ways to deal with that is you can preemptively mark a 0 point on stock if just to be super careful, and then you can reference off that point and like keep your original 0. But say you already cut like some holes into your material, you can use any reference points, be it a hole, being it a specific contour, really anything you already machined, and then you can line up your spindle with that. And in the CAM software, like here, I've got an example of Fusion, where I actually go and change the 0 to that reference point. Then I re-export all of my operations to use that new reference point. So I can 0 at that hole, and then all the operations go on as normal, which might be a bit off, but if you're careful, it should only be like maybe 100th or like 5,000th max, unless like it's a really big hole or something. Then another option is to use that reference point to like measure its distance from your original 0, then move that distance and reset your 0 at where you think your original 0 was. So I've got just bigger pictures to show that I actually just moved the origin with the stock point, or selecting the stock point in Fusion. So, any questions?
Does
Okay.
I have maybe a question for the audience. Does everyone here understand that you generate basically your G code with Fusion and then you give it to your CNC? Not sure. I mean, if you're new, like Dr. B has said, maybe you're not planning on using Fusion. Maybe you're planning on using something else, but maybe we should level set here and understand, just see if people understand some of these terms in Fusion and things.
Yeah, I think we do all of our CAD in Onshape, and then initially we used Kirimoto, which is a free web-based sort of plugin for Onshape, but it's really super rudimentary. You can't do anything complicated. If you want to cut out HDPE or wood, maybe it's okay, but it's not going to be able to do much more than that. We moved to Fusion 360 last year and sort of had figured out how to do contours and pockets and surfacing and things. But our CNC was a very basic machine that couldn't do metal at all. It's a mostly printed CNC from V1 Engineering, which was, if you put a big piece of polycarbonate on there, it's going to shake itself to death. We were lucky to do, 1x1 parts. We've got a new CNC this year that we haven't figured out how to use. So I think we'll still probably use Fusion 360, but we have a new mentor that knows Mastercam because he does all this stuff professionally, which is similar. And I think we can also get for free from First. So I understand what you're talking about. I'm the team expert other than Nick, who's just joined us. So this is really cool to learn what you're doing, and I understand what you're saying. But yeah, it's a tough learning curve to go from CAD to CAM, because designing a part in Onshape or some of the CAD software is not super hard. You just extrude it and move it and make the shape. Figuring out what to do with the material you've got, the machine you've got, and the tool that you've got to make an actual part out of a material is not straightforward. It's not like pressing the button on a 3D printer. So it's actually really impressive, I think, what you've done, because honestly, carving aluminum is our dream, and you're an expert at that now. So we hope to get to that this year. But I get what you're saying, and I'm trying to catch up. We are aspirational in our CNC dreams.
Okay. I think I'm gonna move on now, but yeah, it's always good to be trying to figure out like how to get to the next step or how to improve. I It's just a constant process. Um, so this next section or next two sections are about being efficient with resources, be it time or general resources. Um, uh, so just for a bit of context, for our CNC, it's an Omeo, which is it's I think West Coast Products sells it. But anyways, it's like the actual machine that's got a control box. Then you give the control box commands through a laptop. Um, so we have a dedicated laptop or computer for controlling the CNC through its control box, and we're doing it that way so that uh, you're not really doing anything else on the laptop, and so there's not really anything else you could do to accidentally interrupt a cut in process by sending the wrong command. And then you can also like prepare operations for, or you can make your operations for the next part while you're doing the current one. So it's good to have like whatever you're using controlling the CNC to be isolated. Then, in a similar sense, having all your like cam setups, like your tooling or your fusion templates, or I'm not sure what the master cam equivalent is, but having those in a central place, like on a dedicated computer or on a GitHub, um, can be really helpful because you can use the same templates and tools in your CAM softwares across computers. And say you need to make an update to a tool or to a like really important template, you can just do that in one place. Then you can have the other computers updated from that one place. And then during downtime, I like to spend my downtime say in between or while I'm waiting for a part. Just I like to spend that playing with the machine, or of course doing non-manufacturing tasks, but that's lame. Um, so I've done a lot of like small test cuts and scrap to just kind of like tune the CNC and increase its speed. Just doing like one variable for every cut, just running a quick uh, like oval pass, then using the like audio feedback of how loud the tool is, if it sounds like it's cutting really good or really bad. I can't really be more specific than that without playing some clips that I don't have. But then also looking at your cut and seeing uh, if there's a lot of markings, if it's just looks really clean. So using the feedback from your cutting in your scrap. Then I also like to experiment with how I enter the stock. Like I've played around with like boring a hole before like sending tool plunging down to enter from that hole, or just down and uh, ramping down, then doing multiple depths. So I guess ramping and then doing a fast operation for the rest of that Z, ramping down to your next Z, doing a fast operation, just kind of playing around with the like what you're given or the tools you're given in Fusion or Mastercam or whatever cam software you're using. Just playing around with those to try and increase your efficiency. Then another thing that I'd like to spend my downtime doing is making accessories to the CNC to like make to increase its functionality, like making a vise to be able to cut smaller, like more 3D parts easier besides like gluing them. Making a chip collector to reduce the amount of was it cleanup during or like after a cut, and then like learning G code commands just to get a better grasp of what the CNC is doing, what's being told. And I also like to have fun with the CNC. Like I cut a little was it like a little Star Trek Delta insignia when I had a chance, just playing around with some brass. So here we've got some examples of like little projects I've done. So I've got a was it I've got the vise that I mentioned earlier. I've got some replacement wrenches for what we actually use to like tighten our collets, because the ones that came with the CNC aren't the greatest. Then I've also got like an indicator to show that coolant's running. So there's a lot of fun things you can do with the CNC uh, that can make the CNC work better. So I would spend time looking into those. Then, along with being like or working on improving your efficiency cutting, um, do improving your efficiency when actually programming using Fusion or Mastercam, whatever you use. Um, I'm guessing there's an analogous feature in Mastercam, but Fusion has a thing called templates where you can right click on a program or on an operation, then you can save it as a template to use later. So you can save like a specially tuned program, say you're entering a certain way and you want to keep it and you want to apply that to another program. Or like I have like multiple bore operations where it's preset with a tool and I just have to like bring in the template and then it just automatically selects all of the holes that tool can cut and it can do that real quick. Then you can just have preset options for operations. Then to make these, it takes a bit of time, and to improve them, it also takes a bit of time. So using your time off season to like make it so you can program quicker. You can also update your templates if you learn something after a cut, and there's just always new things to learn with them. And a lot of the time, you can go faster. Sometimes that's a bad idea, but most of the time, it's a good idea to go fast. I think I've got one or two more slides. Then I've got a question slide. So if you could wait until then, if that's cool. So then I've just got quick for actually making a template. You right click on your operation, then there's a little stores template box where it brings you to a new one or a little window to actually store it. Then to call upon it, you make a setup. You right click on your setup, then you can choose create from template and choose either ones you've used recently or ones from your general library. And then I can go, if people need, I can go over what setup is and stuff. But the last thing I have in this section is dealing with burrs. So it's really nice to, if you're able to limit the amount of work you need to do after machining. So, and burrs are a big part of that because say you've got a plate right in the middle of a robot. I've put my hands in robots. I've like reached in there. I don't want to come out with a lot of cuts. So you need to make sure that your parts are like deburred and that they're safe. So you can limit the amount of deburring with a chamfer end mill, just having the machine cut off all your burrs and give it a nice finish. You can do a spring cut helps. Might not with a upcut bit, but a spring cut can take off a lot of your burrs, especially if you've got some material like remelted to your part. And then my favorite, you can outsource your deburring to programming because I've talked to some programmers and they love to deburr. Apparently, it's relaxing, so keep that in mind. You can outsource the manual labor. Okay. Well, what was your question, Dr. B?
Actually, I have two. I love outsourcing the programming. Actually, we have to steal the parts so that the mentors don't do the deburring because they love it too. So honestly, two things. The one is if you could share what you do for your lubrication and your little lubrication flow meter, that would be really cool because we have not done aluminum at all and don't know what to do with that. So what you've used for equipment and solution and your little flow meter would be cool. And I forgot my other question, but by the end of your answer, I'll remember it.
Okay. That flow meter was for like a water antifreeze mix we use for our spindle, because it's water cooled. So that just shows that it's actually being cooled and you're not generating a ton of heat accidentally. But for our coolant, we use, I don't remember what they're called, but they're like an adjustable tube. Anyways, we blast our part, or the tip of our bit, and in general our part, with isopropyl alcohol, because we use that because it just cools the bit. It gives a bit of lubrication. Then it also evaporates in air. So say we accidentally soak the table, or we give way too much, then over time it'll just go away and we won't damage our table, assuming we don't give it too much. So I guess for lubrication, just having something where you can, or having a tube that you can aim and that you can keep in one place, and then having whatever Scott
And you've
put
got
in
a
there.
little like a reservoir with that's cool, like a reservoir with like a little fish pump kind of thing. I've seen those.
Yeah.
So I just pasted the link for the mister that we bought through Amazon, $18. And then we connect to our air compressor. And so basically the little tube that goes into your bottle of isopropyl alcohol just siphons from the airflow. And then you can adjust the valve to figure out how much it's going to siphon out. Does that make sense?
Yeah, I've seen that. We have no experience with that, so that's cool. I thank you for the link. That's really cool. My second question is how and if you have to do like a tool change. We don't have a tool changer CNC. It's like me with taking the thing out of the collet. How do you do that in terms of process in Fusion 360 to put in a pause, take out the bit, re-zero the thing, and make sure that you're able to keep going, or have you not done that? Because that's intimidating to me.
So in terms of the actual program in Fusion 360, I export like related or programs with the same bit. I export all the programs with the same bit I can as one file, but then say I want to change a tool, I'll just export all of one program, or I'll export the programs of one tool, then export the one with the next tool like as two separate files, and then we don't have a tool changing CNC either. I just loosen the collet, take the bit out, and then put the new one in, and then uh, I use a 1/4 inch bit that I know the diameter of, 0.249 inches. Then I take the spindle, obviously off. Uh, I move it down, and then I move it down to about, or below, 1/4 inch from the table. Then I just move it up by like 100th or 1,000th until I can push that bit under it, and I move it down, um, and I go up by thousandths until I can move it under without scratching the bit. So that just lets me manually zero it or manually zero the tool after a tool change.
And you'd put the XY in some location, just like you do if you had a failure with power or whatever. You just have a location where you start, or you try and just keep the device with all of its zeroing information in it while you're doing that change maneuver.
Our CNC it keeps its zeros between operations. It knows where it is at all times, unless like the reference goes off or something. So generally, I just move it off to the side and it can go back. But if you need to change your tool, yeah, refinding the zero that way would work.
Isaac, you don't power down the CNC, do you?
No, I try not to power down the CNC if I don't need.
So then it maintains its X and Y that way.
Yeah. Ben, you have a hand?
Just for Dr. Beer's reference, we also have another method of referencing tools. It's a little bit more complicated. The old build student that came back and helped us, created basically a touchpad. And so what our actual process usually looks like when Isaac's not doing it is we run a fake tool change. We have a tool in the call it, and then we run a fake tool change, and that sets basically your baseline length of tool. And then every time you change a tool, you touch off of, we have a macro that runs every time you do basically an M6, which is a tool change macro. And that subtracts the offset from that first tool, and it adjusts the length of the tool inside the CNC's memory. And it's in G code. There's something called a tool offset that changes. The problem with doing it that way is you have to not think about it. You have to just trust the process. And a lot of the stuff that Isaac does, he has to think about a lot of things. And so it doesn't always work as well. But if we have new students doing it, or if I'm doing it, I do it off that touchpad.
I think you almost need it both ways. You need to trust the process and then verify, right? Make sure it's right. But that's really cool. Cause I think that's what we need to figure out. Cause honestly, we've never cut a part with more than one bit because we just didn't know how to do it and we didn't have the tool set to do it. And so that's our goal for the year, is to figure out, how do I clear a big area with a big bit, drill the little holes with a little bit, and then do the outside with something else that doesn't take forever. So that's really good advice. Thank you.
Reese, it looks like you're raising your hand.
Yeah, so I was just wondering, what do you guys do about chips when you're milling for CNC?
Ooh, okay, so over the summer I got so I made like a dust collector. So I have a vacuum tube that normally threads onto here, and then I have a little hood for normally the spindle would go in here, and then your bit would be down here, and it creates a seal. So I would say a custom dust collector with like an external vacuum. So that's a really good project for if you've got time.
Okay, neat.
Something else. Another way to do it is you can just have a vacuum and you hold the end of it like with an extension, so you don't have your hand near the bit, but you hold the end of it to where the chips are coming off.
Yeah, that's the way I've seen people do it in the past. Yeah, but the dust collector thing, that's a neat idea. I like that.
Yeah, it's a really fun project. Any more questions before I move on to the next section? Okay. So now I want to talk about some like being efficient with resources. So something I like to do whenever I have a good amount of parts to cut out is I like to arrange them in an assembly and on shape, and then arrange them so that they're in like a small amount of space, or as small amount of space as possible, and I don't waste a lot of material. So there's a couple benefits to like exporting it in an assembly this way. It makes it so you have all your parts in one file, so you can use the same operations on them, and limit the amount of tool changes. Say I want to do a external pass on all these teeth of the sprocket, I can just use the same operation for cutting this one as I can for this one. So that's also less time programming, because I don't have to program a whole separate part, say they're different parts. That also makes it so you can use the same zero, and you can just keep working on out of the same file. Then you can also be more efficient with your stock easier that way, without having to worry about, say, accidentally setting your zero so that like part of the part hangs off the stock. So I've actually got a bit of a what was it, an example of how you can use the same program with the same file. So I have the like arrangement of parts over here. Then in Fusion, I have um, just one operation that does all of these bores. And so that's with one tool, no tool change. So I just go through and do all of those holes, and then I can go through and do all of the cuts I can with a larger 1/4 inch bit. So that is just considerably less programming for the amount of parts you're making. And oh, what's your question, Dr. B? It's a bit,
Hey,
or we
I'm
have a
just
bit.
wondering, after you do that first bore operation, do you then like screw those parts down through those bore holes? Because we
Yeah,
use tabs for some things, but those are painful. So obviously, if you're doing a tool path and then you're pausing and changing your bit, do you just figure out which things need to be screwed down and screw them down?
yeah. Generally, I try to have like the laptop I do the cam on near the CNC, often facing it, so that I can reference which holes I can secure in and which ones I can't. Like, um, this is really small, but say one of these holes on the ends of these hats, it's really hard to secure there, and I need to know which part or which hole are those holes for the hat because I need to use a special type of screw that has a smaller diameter. Um, so yeah, I generally secure those as or after I've done a tool change, just because the operation's already paused. So speaking of tabs, so another way to be efficient with your resources is to save your cutouts. So I like to like secure a large like cutouts. Say uh, I have a part with a really large open middle. I like to save the cutout there as scrap because then I can use it to test settings or make smaller parts. Then it's also faster to do a contour like cutting operation than to do a pocket operation and like cut out all of that extra material. So some ways to secure those are, say you're using screws, just like drilling the holes to secure it manually, or making a manufacturing model, which I'll touch on in the next slide, to actually have the machine cut out those holes so you can just secure it when you're secure the rest of your stock or the rest of your part. If you're using tabs, it's really easy. You can just add your tab settings, but it is a pain to deal with them, especially with aluminum, and especially if you don't have your settings like dialed in. But that's just within the contour operation. If you're using glue and tape, it's pretty easy to keep your cutouts because you just need to make sure you're keeping your stock cool and you're limiting the force exerted on the part, which you should already be doing. So it should be a piece of cake. And if you're trying to save a cutout with a vise, I don't have any. I don't have any suggestion for you because that's not a good idea. So here I just have like kind of diagram of saving or saving the cutouts, the process for doing that. So what I like to do is I like to make a manufacturing model where this is the original part, say without any of the, well, without that middle piece. Normally it's got a big hole here, but in the manufacturing model, which I do in a separate document, I just make an offset for all these curves and then offset it the width of the bit I plan to use. Then I uh, ex- I make an extrusion and add holes to it so that I can secure it. Then I add a little channel between the part or the actual part and the extrusion in the middle that I want to save. And then I make that channel like 0.001 or 0.0001 inches thick so that it's the inside and the actual part are the same model, so that I can export that as one file and I can keep those holes and use them in the CAM software. And so when I do that, I generally take off, I add like a negative 0.001 offset for actually cutting out that channel. But then after, say, you do that, then you add all your holes and secure it. Once you're done with the part, you can take off the stock you saved, and then you have some scrap for doing test operations. Like I have an example of some scrap here, not from the middle of something, but I have a ton of like little channels that I like tested feeds and speeds on and ship load and all sorts of stuff. So I would heavily recommend saving scrap when you can, especially once from a part. And the last thing I would have for being efficient with your resources is finding good sources for them. So pretty much all of our stock for Nightcrawler comes from secondhand sources, just because it's cheaper and it's less wasteful. So we get a lot of our plastic from Axeman surplus stores. Sometimes they'll have some really nice polycarb for a good price. Then we also get plastic or aluminum cutoffs from Cormark Metals in the Twin Cities, because a lot of companies need a big sheet to for whatever purposes they're using it for, but then they have the smaller part of this big sheet that they can't use, so that's just sold at a discount, and that's perfect for applications. Then we can also get plastic and aluminum from retired field elements. Actually, both of these pieces, I have two examples of like for other slides, but both of these are from retired field pieces. Then we can also get scrap from parents or mentors. They can bring it from their work. That's how we get a lot of our thinner plastic. Then, of course, some occasional dumpster diving, like how that alumni got the CNC. So I would consider like pursuing, or also to get stock, I would consider pursuing in-kind donations or sponsorships from local companies, because again, their scrap can be perfect for what we do with it on or in FRC. So, yeah. Oh, wrong window. Any questions before I go on to the next section? Cool. Okay. Then the last thing I want to go over is like machine and tooling health. So I've got some like general stuff for tooling and wasteboard. So one thing to keep in mind is that tooling is replaceable, but you should treat it to last, because one bit, especially a like quarter-inch or larger bit, can, if you don't dull it, it can last you for a good couple of years. So a good way to make it last is to push it to about 75 to 80% of its limit, so that you're not accidentally taking off too much material. If like you have a slight error in your program or something, so you give yourself a little margin of error, and then you should always be using coolant or lubricants when you're cutting metal, just so that you don't build up too much heat, because the heat is what actually dulls your bit. Then another thing to keep in mind is how deep you're cutting. So especially when you're doing like a pass and sheet goods, you have 180 degrees of contact with the bit when you're cutting a channel. I have a little diagram here. So as this as this hypothetical bit were to move forward, for every amount it moves forward, it's always pushing, or it's always going into material on in front of it and to the sides of it. So you're taking off a lot of material at once. So if you can, it helps to preserve your bits if you cut shallow and limit the amount of material cutting off, or sometimes if you cut slow with low chip load, because then you're just cutting less material. It's less stress on the bit. Um, then another thing to keep in mind, I've got a good example of this on the next slide or of why you should do this on the next slide, is you want to set your zeros accurately, especially if you're using chamfer end mill or something that isn't just a flat end mill, because if you accidentally set your zero deeper than you think, you could do a full depth cut when you don't intend it. You could run a part of the bit that doesn't have any cutting edge against your material. There's a lot of bad things that can happen when you don't set your zeros accurately. And then something kind of similar is you should avoid plunging inside stock, because your machine might be able to do it because your cutting edge is spinning and you go it's cutting the stock as it goes. Um, a lot of end mills are not designed to just plunge, so that's going to wear them out quickly. That's going to put a lot or that might dull the tip of your bit, which is the last thing you want to dull, because that actually allows you to ramp, that allows you to cut the material at the bottom. Then also say or you want to give your spindle time to spin up. Something I've ran into with our CNC is I'll hit the go button and we have a pause just to confirm, like, okay, the spin is out of the way, you want to run the program. So when you hit the go button, the spindle turns on and it immediately starts moving to the part. And if you have, I've ran into times where I have the spindle too close, or I have it close to where it enters, so the spindle doesn't have time to like speed up. It doesn't have time to get to the RPM you want it to be going. So it enters and it's still speeding up, so it's not going as fast as a spindle should, while it's going the feed rate that it should be going with a higher speed or a higher spindle speed. So it's actually taking off, or it's cutting off a higher chip load because the spindle isn't going as fast. So you want to give your spindle time to speed up. Then also, securing parts. I talked a lot about it in a previous section, but if you don't secure your part, then there's a good chance that it'll like jump around after it's free and not connected to anything, and that might damage your bits. Then just a little bit on the wasteboards before, or on wasteboards before. I think this is one of the last slides. Is it's also replaceable, but it should also last. So one way to deal with or to improve how long it lasts is to pre-drill your. If you're using screws, pre-drill the holes that you're going to screw into, because when you actually screw down, the threads are going to pull up on it's going to pull up on the wasteboard, and if you don't have a hole for it to go on already, it's going to displace all that material up and cause a bump, and it's going to make your table not flat there, and it might tear the table. Whereas opposed to if you pre-drill, the threads are still going to pull the material up a bit, but on the sides of the screw, the wasteboard has space to compress. And then lastly, don't cut too deep. Don't cut too deep with your cutting moves to avoid scoring the wasteboard too much. So I've got a lot of pictures coming up. So that was a lot of talking, but now some visual aids. So this right here is a chamfer end mill, and these are sprockets that I was trying to cut with the wrong Z set for this end mill. So, or this chamfer bit, I don't remember the terminology. But it plunged too far. Then it started cutting these sprockets, and it was pushing the. Not all of the bit could cut the chamfer, so it was actually pushing material down into the side. So it was cutting too much, and it clogged up the bit. But it also made these sprockets unusable because they're it kind of squashed the material, so the chain couldn't go on there anymore. Then I've also got a similar thing happening with a 3-flute bit over here. I was testing it during some downtime. I was doing some test cuts. And I had way too high chip load for a 3-flute because these flutes are tiny. They can't take a lot of chip load. But I ran it too hard with too much chip load, past its limit, and it aluminum got stuck in there, and it took like 3 hours to get it out. So then I've also got an example of what happens when your bit gets dull. So say you ran a bit too hard and you dulled at cutting edge. This one is fine, but this one over here, it has this like scale or all of this chip or all these chips that melted back onto the part just because of how much heat was involved. And the cutter was more pushing chips than actually cutting them. So uh, it takes a long time to get rid of this junk. And so you just want to make sure this is why you don't dull your bits and use the dull bits. It just doesn't cut anymore. It just pushes material. Then last thing I want to go over is I've got a quick CNC fail video here of my own. A bit loud. Then over here, cut a bit too deep, and it comes up and I break it. So this is a good example of why you actually secure your part, because I had this whole vice assembly secured with I think 4 screws, and that was not enough. Uh, the vice got pulled up and it actually broke the bit. It damaged the waste boards, and there was a lot of force acting on this just because of how deep I was cutting. And yeah, be nice to your bits. I'm just gonna run that again, but I like this video. Okay, then one last picture, then I'm done with my presentation. This is our old wasteboard. So, um, so over here, that's where we use it the most. And I've got a lot of like, there's a lot of craters here just because I didn't pre-drill any of these holes. And so all the material was forced upwards. And this, it's just not level at all. Even with surfacing the board, it would take maybe taking off 1/100th of an inch of material to get it flat again. Over here, I didn't tighten the collet enough, so it ran. Was it? The bit fell and actually cut all of this like 3/4 of an inch deep into the wasteboard, so I couldn't fasten any holes that happened to fall in this groove. And then I've got a lot of water damage from isopropyl, where I just let it, uh, where I let the coolant just drip down accidentally. So be nice to your wasteboard so that they can last you longer than this one did. This only lasted about a season. Oh, okay. I guess I got one last thing. So your tool size matters. Those smaller tools are good for precision, but they're you can't get as much chip load with them, so you can't get as much feed rate because they just have physically smaller flutes to cut. Then also they have less material on them since they're smaller, so they're going to be weaker. And since they're weaker on harder material, it's really easy to break them. So limit a good rule of thumb is to like limit how many tight spaces you need to cut on harder material, just so you don't have to risk breaking any small bits. Then large tools, they don't fit into a lot of places, but you can push them with a higher chip load and a higher feed rate because they have larger flutes to actually cut the material. Then since there's more material on the actual bit, because it's larger, it's stronger, so you can run it harder. And that's all I got. I've got a QR code for the slides. I can also put them in the chat if anyone would like the link to the slides. I also have my email if you have any questions or comments in the future.
Hey, Isaac.
Yeah.
Nice presentation. Thank you, young man.
Thank you.
Now that I complimented you, you owe me.
Oh, okay.
Hey,
Well, what do I owe you?
we just bought a new ship Poco. I think it's a 5 Pro. How do you know anything about that machine?
Was it Chipoco something Pro?
5 Pro, yeah.
I don't know much about the machine. Is it belt driven?
Pardon?
Is it driven, or the axis driven by a belt?
No.
Okay. I don't really have much to say on that machine then.
All right. No, that's fine. Then I'll reserve my next question with Scott on a different time. Thanks.
Any other questions?
I have a piece of advice to share. If you're going to use an air compressor for your lubricant, do yourself a favor and go get an ultra quiet air compressor. Harbor Freight, Menards, Home Depot. Man, you'll never ever regret buying an ultra quiet air compressor. It's the greatest thing in the world.
Tom, do you have a question?
Yeah, Isaac, great presentation. It was really wonderful. I'm trying to remember what you said at the beginning. I can't remember how big your team is. Do you guys try and get everyone approved for CNC use? What percentage of the team, what head count actually gets approved, and how many of you who are approved actually do any work, things like that. And then I think you said 40 parts on this past season's robot. Do you have a sense of how many hours of machine time went into those?
Well, for the number of people we have approved on the CNC, we have a couple mentors. Then I'm really the only one who has done any work on it, just because we haven't really had an experience or a lot of experienced people in CAD, which has kind of been our stepping off point for CAM. I'm hoping this year to train more people into that, but I've got one or two people who I've shown how to use it and who might be able to start getting more in depth this off season and going into the season. But that's a big priority for me this year, is getting other people trained. Then in terms of cut time, it was 49 parts. I would say maybe 4 days throughout the season, and so at least 100 hours, just with all the prototypes and past iterations and spares.
Do you how? And I should probably, part of that question then would be, how tightly do you monitor it? Do you ever run lights out?
We do not run lights out. It's always being watched. Maybe not too closely, because sometimes I've done CAD work or other programming, and I've just checked on it, just glance over, every 10 minutes or something. But there's always someone there with it, listening to hear that it's going correctly. And generally operations are pretty short. They're either pretty short or they're long enough where we want to make sure that they don't crash. So it's always got something, or it's always got someone looking at it.
I'll defer to Sam. I would have more questions kind of along those lines, but thanks so much, Isaac.
Yeah. Sam, what's your question?
Sure. Yeah. Well, sorry to stop you, Tom. I was curious. Scott mentioned the the quieter air compressor, like how bad is the sound from your machine? Like, I think we have a problem at least where, at least we have an older one, and then we just got an Amio too, and it's kind of like it shuts down. Like, it's hard to talk in the shop when it's running. There's no enclosure on ours. Is there anything you've done to like mitigate sound? How do you do shop safety around it? Those kind of things.
Well, we have an enclosure on it, which maybe makes it about like 5/6 noise. So it doesn't help much, but it helps, or it doesn't help too much, but it's a considerable. It makes it nicer. But generally, uh, our shop is, or we have a space attached to our shop. We have a gym that we're able to use, so, or a half gym, quarter gym, whatever it is. But we generally have people only going in the shop when they need something, say to grab a tool or to grab like some parts, or just grab something or use a machine quick. If anyone's in there for an extended period of time, we have earmuffs that they can use. So I generally just have them on a lot of, or for most of the meeting. And then if someone's going to be doing or using a drill press in the shop, or using our bandsaw, generally they will grab a pair of earmuffs too.
Okay, thanks. That answers it. I was hoping someday I'll find somebody who's like, "Oh, we did this and the sound was bearable," but I figured that's probably just not going to be a thing. So
yeah, I mean, you can always like.
We converted from a DeWalt router, which was super noisy, to an actual spindle, and that helped, but it's still super noisy.
Okay. Yeah, because I think our spindle is really loud, but honestly, most of it comes when you're cutting the metal, and I don't know, I don't know what else. Okay. I was gonna ask when you say,
foam?
oh, say that again. Sorry.
Oh, soundproofing foam on the enclosure or something.
Yeah, we might try it. We'll see. We're kind of, I don't know. At least it drives me nuts enough that it's probably worth trying. So, I was gonna ask then, when you say pre-drill the holes to secure things down, do you just do that by hand with a drill, or are you actually putting that in your program, or how does that go?
A lot of the time, I'll have, say it's like a hole I'm putting in some cutoff, or just a hole in the part. I'll have the machine do that, but then I take a smaller drill bit and just do it by hand.
Okay. And then I was wondering, do you ever use drill bits on your on it, or are you always just using the cutter and just plunging every time?
We do not use drill bits, and we do not plunge, or we always want to avoid plunging, just because of the wear it puts on the bit. What I have the machine do for doing small holes is do a ramp operation and just kind of do a shallow ramp down, because generally with an 1/8 inch bit we can do number 8 holes, number 10 holes, quarter 20 holes without much stress on the bit.
Okay, that makes sense. I was kind of curious what other people are doing. I've heard of teams using drill bits, and we use them on and off, and so it's a lot quieter. They cut nice, but it's also, you're dealing with all the tool change junk then. So okay,
Yeah,
that's all I had.
Okay. Lily, what's your question?
I don't know much about CNCs, but I asked like my team's like dedicated CNC user, and he's asking if there's any like tips about how to like train new students on CNC, or like any of like the best practices to train people on CNC.
I'm gonna level with you. I'm not the best person to ask about training on the CNC. I haven't been the greatest about that this last year, and I'm hoping to get better with that, but I don't really have any tips for you. Scott and Ben, do you guys have anything that you want to add?
Well, I mean, obviously, we want to have the students shadowing Isaac as much as possible this fall, so they can see what he's doing and work side by side, sort of one-on-one type of training. For best results, maybe it really takes a lot of extra effort to be a good machinist like Isaac has done. Isaac has put in so much of his own time watching YouTube videos and just testing cuts and parts. I will say I learned how to run a CNC by watching a ton of YouTube videos and finding people that were talking about chip load and understanding how do you optimize feeds and speeds and things like that. It's like being a good programmer. I mean, I run a lot of our programming type tasks, and it's the same type of thing. If you want to be a good autonomous programmer, you're not going to be a great programmer if the only time you write code is at meetings. And it's going to be kind of the same thing with running a CNC. Is it takes a lot of extra research to really become familiar with what it takes to run Fusion 360 and what it means to do all these different operations that Isaac's talking about with ramping and boring and things like that.
I was going to say that I initially set up the CNC for the team. And what I did is I created 2 different checklists, one for basically what you do in CAM and Fusion, and one for cutting on the machine. Basically just step by step. The stuff in Fusion is very simple. It was only for boring holes and doing contours, which is cutting out. It's like basically just like checklist of everything that you need to do in the program to get G code out of it. And then I had a checklist. It's like every step you need, like you got to reference the machine, then you have to set, secure your materials, and then you have to zero the machine, and just having a step-by-step checklist. And then I ran students through that, watching them cut, and we're still learning. It's something that if anybody else has ideas or tips, we'd like to hear too.
Does the silence mean that people are out of questions? It's good timing. It's 8:30 now, 8:29 on my computer. So, going once, going twice. Any final questions or thoughts from anyone? All right. Thank you very much, Isaac. Excellent presentation.
Super useful. Thank you, Isaac. That was awesome.
If you enjoyed this presentation and you're going to Jumpstart, send them to Isaac's session. He'll be giving Jumpstart at the Medtronic Jumpstart. Right? Isaac, it's just Medtronic. You're not going to St. Cloud too?
No. I didn't even know there was a St. Cloud one.
So with that, I will say once again, please consider signing up to host a conversation or give a presentation. If you're like Isaac and you're giving a presentation in some places, this is a great place to practice, get lots of questions and feedback from folks. And otherwise, just sign up to host a conversation because it's something that you're interested in sharing or interested in learning more about from other teams. All right. Thank you, everyone. I will see you next week.
It's gone.
That's it for this week's FRC Roundtable. Join us live all season long, every Sunday night. Visit the website at team2052.com/roundtable to sign up for weekly invites. In the meantime, keep building, keep learning, and we'll see you next week.